What if, just now when we talk about x, let's do a quick recap, okay? What we're saying is this. Now we have x, expected value of x, variance of x, correct? Variance of expected value of x is like this, one data, one data. Now what happens now if I say 1, 2, 3, 4, 5, like that? I call this x1 plus x2 plus x3 plus x4 plus x5, like that, over 5. This is what I call x bar. Correct? Can? That means 1, 2, 3, 4, 5, x bar, 1, 2, 3, 4, 5, x bar. What is the expected value of x bar? That means the long-term average of x bar, which means I pick 5, divide by 5, I pick 5, divide by 5, pick 5, divide by 5. The long-term average of this value. We have shown that this one is the same as this. Correct? We have also shown that the variance of x bar, which is the spread of this x bar, 1, 2, 3, 4, 5 divided by 5, 1, 2, 3, 4, 5 divided by 5, is not the same as variance x. It's actually variance x divided by, in this case, 5. To be more general, is n. Now, actually, does it make sense? I usually like to appeal to your good sense. Look, can you have attention? You would expect the sample mean to have a spread that is lesser than the original distribution. Why? We talk about height. Just talk about height. When I randomly pick one guy, correct? I could have been unlucky and I picked a tall guy or a short guy, which are extreme ends. Follow what I'm saying? Yes, spread of data. Now, if I randomly pick 5, chances are, when I pick the 5, it's extremely unlikely that I'll pick all 1.85 meters tall guys. You follow what I'm saying? I would generally pick, by luck, I would pick an assortment. You follow what I'm saying? So therefore, the spread of the data, it makes sense the variance should be lesser than x. You follow what I'm saying? Now, throughout all this, we have not made mention whether, do you have a record? You want forgot to remind me. Then how? Do I start from, say again? Of course not. I think I what? Never mind. Later I will refer to notes and I start. Must remind me, okay? When I refer to notes, must start. Must click start, okay? Where was I? Oh, yeah. When we said all these, we have not made mention whether x is a normal distribution, Poisson distribution, binomial distribution, or whatever. Now, correct. This will stand no matter what is the distribution. Now, in 6.4, we're going to take a look. What should I do? Can you remind me to click start? Yo. It's start already, what? What's happening? Okay, never mind. Start already. And this will go on record, my goodness. Never mind. Okay. Wait. Now, if 6.4, suppose that x originally was a normal distribution with mean, mu, and sigma square. This is a very important statement, yeah? What we're saying is, if x originally was a normal distribution, the sum of the x1, x2, x3, x4 all the way to xn should also be a normal distribution with this mean, with this variance. Now this one, this mean and variance, we have already shown it in the earlier part. Follow? We now also say that if x is a normal distribution, we take x1, x2, x3, x4, all the way to xn divided by n, which is actually x bar, will also follow a normal distribution where this one, where this is the mean, what's happening? This mean and this variance, which we have also done in the earlier part. Correct? 6.4 actually says this. If x follows a normal distribution, then x1, x2, x plus x2 plus x3 plus x4, all the way to xn, also follows normal distribution, which all of us know. Normal plus normal give us normal. Correct? Then normal plus normal plus normal plus normal divided by n also will be a normal. That's all we are saying, which even without me saying here, you should know. You learn in steps 4. So use this. Example. I love examples because saying talking, yeah. Don't know what you're doing also sometimes. Okay, let's better use an example. Height of a population seems to follow a normal distribution 1.64. It's more logical. My example 1.7 not very good, but never mind. Now a random sample of 80 people is taken from the population. Find the probability that the mean of this sample. Now, this mean of this sample, in my head, in your head, when you read the question, you must know that this mean of the sample means mean of the 80. Okay, notation. This x1 plus x2, this is let x bar be equals to x1 plus x2 plus dot all the way to x80 divided by 80. Now from the result in 6.4, we know then that x bar follows a normal distribution with the same mean but a variance that is 0.205 divided by 80. Does it make sense to all of us? Sorry, this is 5, okay? When you key into in the calculator, I see quite a few careless mistakes in the normal distribution question. So fast. Since end now, serious? Okay, never mind, quickly, just 30 seconds. Now, this one. You all know lah, okay? Just remember when you key the GC, don't key in this, okay? Key in the square root of this, okay? Then you're done. Find the probability that the means exceed 1.69. Key into a GC, you will get this. Done. We should be faster next lesson. Alright, thank you.